Now it's my pleasure to introduce our speaker tonight. I think known to many of us already. He's given us at least 2 talks previously. Dr. Jacob Martin, also better known as Jake, I think. Jake is a lecturer in physics and astronomy at Curtin Uni. Apparently more details of his illustrious career are going to emerge during the talk. His journey through, I think, science, faith, climate change especially. But for me, on my personal note, for me, Jake is a splendid example of a practicing Christian working at the cutting edge of science, and he's superbly qualified to address our topic today. So over to you, Jake.
Thank you so much for that introduction, and I also want to say thanks, Mark, for it's great to be here, and it's great to have so many people coming today to hear me talk, and hopefully it's not too boring. Before we start, though, I thought we would just begin by just explaining why there's cameras, because I think that's really important. So we usually record the lectures and we put them on YouTube, and that means that people all around Australia can enjoy them, and there's some great talks as well I recommend on the ISCAST website that you can look at as well. And so that's what Mark's doing up the back, but that's just recording my head and the slides. And we don't put the Q&A afterwards online, so that we can keep that sort of a private thing, so we can have better conversations, to be honest. When I'm lecturing, actually, the quickest way to stop students asking good questions is to record it. And then the other thing is there's another camera here, and this camera is specifically for a documentary that is being currently filmed in different parts of the world on climate denial or climate science denial, and that's part of AXA Insurance that basically has asked a documentary company to come up with training material for companies to explain how to engage with people who are sceptical or who have questions about climate change. And they're recording me. They're actually not going to be showing the talk. They're going to be just seeing an interview with me before I give this talk, and also just some shots of me while I'm talking. But I'm also just going to be explaining how I sort of engage with different people and talk about it. Now, the reason I'm telling you this is that at some point the camera will move to the back and film me with some heads, with some backs of heads. Now, because this is a private venue, under Australian law, which I think is quite good privacy laws, is that you need to have signed approval for someone's head, even if it's the back of it. So if you would not like to have the back of your head filmed, then there's some chairs over here that will be not in the frame, and so that's one way you can hide out of frame. I just wanted to let you know, and Louise here has some more forms if anyone has not filled out a form and just giving permission for the backs of their head to be filmed. So yeah, just wanted to get that out of the way at the beginning, and I'll explain why this talk came about to begin with. So as mentioned, I am a physics lecturer, and I don't know how I ended up there. I seemed to study physics, chemistry, and engineering, and all sorts of things, and I ended up in a physics department. And I think that's because I love materials. I love making materials, and at the moment, I'm part of a group that's making a lot of battery materials and materials for hydrogen storage. So renewable green technology is sort of what we focus on, and we try to discover how to make better batteries. I would love a battery that I could charge in like 5 minutes. That would be like the best. That's kind of the goal that's one of the goals of our team at the moment. That's turns out to be quite challenging. And you can see me, I'm in a lab, I've got a glove on, it's legit. So, but I don't want to talk about that today. I'd like to talk about a talk I gave a couple of years ago as part of the countdown to one of the meetings around climate change. So I gave a talk at TEDx Kings Park in the State Theatre, and it was called I Was a Climate Skeptic, the 3 Things That Changed My Mind. Now, this is the talk that got the documentary company talking to me from AXA Insurance, and they really want to understand sort of how what it was like for me to be in that sort of skeptical place, and also in more conspiratorial thinking, I would say, and then my journey. But going through this, I realised that I haven't told the story from a Christian perspective. I've told it to a general audience for the TEDx talks, and for this documentary it's a very specific group of people as well. It's a whole bunch of people at consulting companies and these big international insurance companies, and I just wanted to talk to my community of fellow believers about my journey. So I was praying about this and thinking I would give sort of a more traditional talk where I sort of list out what is a skeptic and everything. But I think what I've come to is actually just explaining my story, so that you can see how sort of I fell into that thinking, and then how different people brought me out of that. And as mentioned, I'm a fellow of ISCAST, and I'm a Christian who regularly attends church, reads the Bible and prays. And if there's no change in my life, then something's not working. So that for me is really important, that faith actually leads to change. And I'd also want to mention that this is a personal account of my views on the climate and doesn't represent views from my employer. Right. So this is where I grew up, a beautiful town in the middle of New Zealand. And this is Cambridge, so it's in the middle of the North Island, a farming community. It's about maybe 20,000 people, and the big industry is dairy, but also horses, so breeding very, very good race horses. So this is where I grew up, and or at least had my formative years. And so I want to explain sort of a little bit of that context of small town in a rural community. So I actually was quite interested in science, and there was a lot of encouragement for science. So the first thing I ever did at school when I was wanting to do a science fair, and this is something that happens quite often where I was growing up, everyone would do their own independent science project, and you had to pick something, you had to come up with it from something online. And the first thing I was interested in is the water cycle. I just learned about it at school, and so I decided to basically try and create a little box that could explain how the water cycle worked with little LEDs, and it was basically a teaching tool that was used by teachers. So I think my mind was on the climate from a young age. And I think that's the case for the community, because it was really important that we had the water cycle, because that really meant that we had the luscious grass that meant that we could produce some of the best milk in the world, just being, if I say so myself. And so, the picture that I sort of was taught was, the evaporation of water from the ocean, and then clouds, and then it comes down to precipitation, and the water cycle. But the thing that really sort of got me into science was a teacher that could shift my perspective and help me think about atoms. So as we go through this, I'll show you lots of atoms, and hopefully that'll be a visual representation of the journey as well. So a very famous set of lectures by Feynman introduces all of science with the idea that there are atoms. And there are lots of different types of atoms, and all of chemistry comes from those atoms. And he basically takes you into a billion times into a cup of water. And you can see all of these atoms. Now, the atoms that we've got here are oxygen atoms, hydrogen atoms, and when they're connected together in this sort of bunny ears sort of arrangement, it's a water molecule, okay? And if you've got a liquid, then they're all jostling by each other. If you've got steam, then they're bouncing off each other. And if you've got ice, they're beautifully arranged in these lovely crystals. So that's the first thing I just wanted to say here. So then when we come to this water cycle, I started thinking about these sort of little jostling molecules of water being hit by nitrogen gas in the atmosphere and escaping from the water as they're heated up and floating up and then forming little droplets when they get high enough, and then when they grow big enough, dropping down on the earth. And this idea that these atoms are cycling around really captivated my imagination. I also loved burning things. Now, I have to be careful how I talk about this because we do have fire restrictions at the moment, so, but something about a bonfire, it's very nice to sit around a bonfire and to enjoy the crackling sound. I've actually since learnt that the crackling sound is this is a little side bit, is because the charcoal is sort of a ceramic and it's like a glass, and so as it's shrinking it actually is cracking, and so it sounds like tinkling like crystal, and it really is cracking glass, really, that's that sound. And of course the heat for all of that shrinkage is from the oxygen in the atmosphere coming in and taking one of these carbon atoms and combining two oxygens with one of those carbon and producing a carbon dioxide molecule. And some of them don't get two oxygens, some of them just get one, that's carbon monoxide. And then there's a bit of water here because there's a bit of hydrogen in there too. And so I loved a good fire as well. Now, just down the road from where I grew up was a big coal-fired power station, literally producing half of the CO2 emissions of New Zealand. And this was a really big deal for the community because of what it meant for people's health. So people were really concerned about a whole bunch of different health impacts of the coal-fired power station because sometimes the wind did blow towards our community. So what's going on there? Well, let's replace the charcoal with coal, and coal's got some sulfur in it, and it's got some nitrogen that's not connected to another nitrogen and a nitrogen molecule, and when that reacts with oxygen you get nitric oxide and you get the sulfur reacting to make sulfur oxide too. Now when that finds those lovely little droplets that I was telling you about earlier, it actually takes the oxygen and gives you this quite reactive hydronium. This is sulfuric acid. And that is not good. Sulfuric acid is the same acid in your battery, and if anyone has had a spill of battery acid, they will know just how corrosive and nasty sulfuric acid is. It literally dissolves things. It can, eat up biological material. And so this is one of the issues. The other issue is that there's lead and mercury and other things in the coal, and this also goes into the air and lands around the community. And so there was real concerns around mercury contamination and also lead, and there was often discussions had about how well the coal-fired power station was actually filtering its emissions. And I can't continue without talking about a very famous tax that was brought in. It was colloquially known as the fart tax. It would probably be better known as the burp tax. And this was a tax to research agricultural carbon or climate change, basically reducing the amount of methane that comes out of ruminant animals, so cows and sheep. And what happens in their gut is that the bacteria will take that grass and they'll digest it and they'll release methane. And so this is methane, carbon with 4 hydrogens. You see, I had to go 3D here. I couldn't keep it 2D for too long because, it's kind of a nice shape, this one. But people were pretty annoyed about this, to say it softly. So the idea that government was going to tell them to stop their cows from farting and burping was deeply offensive. And it was deeply offensive for a number of reasons. Firstly, these people loved their animals, really loved their cows. These people, like a lot of my community, they really love to look after their animals. And really what they saw this tax meaning is saying, well, the only way to really deal with methane emissions is to have fewer animals. And so this was an existential crisis for farmers. Basically, big government telling them what to do And a lot of farmers also felt like they're doing their own research, like they are doing their own innovation, and they're trying to reduce the emissions themselves. Now, I said that half the emissions in New Zealand was from that coal-fired power station. The other half is from agriculture that contribute to the greenhouse effect, and it's predominantly this methane. And so this was a really contentious topic in the community. In church, we sort of tried to keep away from climate change, I think, partially because it was such a difficult topic for a lot of people. And so there were people in the community. I remember one person who'd come over from another country, and he was very adamant that we should do something about climate change. And we had a lot of people who were environmentally minded, and I'd had many chats with different people. And the other thing I want to mention about the church that I was at is that it wasn't anti-intellectual. We had a lot of people who were theologians that had studied for many years the Bible. We had some people that had translated the NIV Bible. We had people that had gone to university. The youth pastors that looked after me had both done film studies and sociology, and I learnt a lot about the world and about academic thought. But of course, all of that was put into a Christian framing and discussed. But what wasn't really discussed was science. And I just wanted to explain what it feels like from a small community when they think of science. At least this is how I thought at the time. So I thought that scientists just did not believe in God. They hated God. So that was my at least what some of my community thought. Not all of them though, but and I just wanted to explain where that comes from, and it's actually mainly historical. It's not actually to do much with the facts. So I'm going to go on my most controversial slide, which is around why the church opposed these views so much. So they were sceptical about scientists, and they were sceptical about scientists because they saw the ethical ramifications of certain scientific views that had been sort of co-opted by people that didn't believe in God and justifying all sorts of awful things. So, and in particular, the eugenics movement we talked about a lot in terms of its origin in sort of 1920s science. Actually, most of the major universities, Harvard, Yale, all their presidents believed in eugenics, and eugenics is the belief that you should control who procreates and who doesn't. And eugenics movement actually led to a whole bunch of forced sterilisation of people with mental handicaps and also people of different ethnicities, and of course the horrors that happened in World War II. Now, if you read this eugenics poster here, and eugenics was started by Charles Darwin's cousin, so there's sort of a link there with the science, even if it's a little bit, it's not directly linked. So eugenics is let's try that again. Eugenics is the self-direction of, what does it say there? Human evolution. And if you look at all of these here, it's different branches of science, genetics and everything, and they all build into this idea that we should, now that we know about how genes are transmitted and everything, we should now control that. And even though it's quite an old view, and it's obviously become a lot less popular for very good reasons, mainly through a lot of Christian critique about the fact that everyone is made in the image of God, and it doesn't matter, if your mental faculties don't determine your worth. I think that's a really important concept that Christians have believed for many years. But the sort of public scientists that the community would think about is someone like Richard Dawkins. That would be a person that they say, yes, a scientist who's public, who doesn't like us. And Richard Dawkins is sort of okay with eugenics. So a quote from 2006 says, "But if you breed cattle for milk yield, horses for running speed, and dogs for herding skill, why on earth should it be impossible to breed humans for mathematical, musical, or athletic abilities? Objections such as these are not one-dimensional abilities apply equally to cows, horses, and dogs, and never stopped anybody in practice." So this is the view that if you interpret sort of an evolutionary history without God, and you consider that humans are the same as animals, then we can do everything that we do with animals to humans. And this was really heavily critiqued in the church where I was at, where they'd studied history and they knew how these views, which we sort of called evolutionism or the eugenics movement, so taking an atheistic approach, these were heavily critiqued. So, and I later met many Christians who did bring together evolution and Christian faith, which is a talk for another day, I think. But at this stage, I just wanted to explain why, if you're in this community, why you would have issues with some of the views that scientists have, because what you see publicly, at least, is quite an aggressive front and a morally problematic one. And I think most people find that it's the morals at the end of the day that really they want to engage with. They're not so interested in the facts and the science. They want to know what it means for us. And they saw a lot of people using science at least to justify some things that they really didn't believe in. All right. The other thing that I got is sunburnt a lot. And I remember going to the largest agricultural fair in the southern hemisphere, a mere 15 minutes away from my house. I used to park cars, and everyone would say they had a four-wheel drive, and they didn't. And then I'd send them down to the bottom paddock, and they got stuck every time. I'd have to drag them out in a four-wheel drive. Anyway, that aside, something at the agricultural fair that I still remember to this day is they had this UV camera that could show you yourself or your face in UV. And this was a way of showing whether you had any skin damage. Now, this might terrify some of you, but it was a really effective way of visually showing what's going on. So this is a person here in visible light, and then they put a filter so that all of the visible light is blocked and only the ultraviolet light is able to be seen. And you can see that on this side of their face, where they've put sunblock, it's absorbing the UV light, and no UV light's getting to the camera. And on the other side, obviously, you can see it coming back. And you can actually see spots as well that are due to skin damage as well. So it's quite an interesting approach. So, of course, the ozone hole this is the classic picture that everyone's seen with the ozone hole. And this really concerned me because I'm underneath that hole. I'm getting burnt. And just to give you a sense of this, you would go outside for 10 minutes if the ozone layer was not over you, or the ozone hole was over you, and you would burn in 10 minutes. You would go bright red. And I remember reading books, fiction books about apocalyptic futures where you could only travel around at night because the sun was so harsh, because all the ozone hole was removed. So, this really obviously concerned me. And this is obviously done with satellite images. And ozone, there you go, 3 oxygen atoms there. And the ozone hole's caused by basically refrigerants, Freon. And so it's got chloro, chlorine, fluoro, fluorine, and carbon. So it's just those 3 atoms arranged like this. Now, this is very similar to methane, but you can see that instead of a carbon-hydrogen bond, it's carbon-chlorine and carbon-fluorine. Now, these bonds are super hard to break. Have anyone done Teflon pans? This is the same sort of deal, okay? It's got very strong bonds. And this thing just does not go away. It's a forever chemical. But it does go away when it gets all the way up here to the very high altitude. And then in the dark, it concentrates here. And then when the sun comes up after the winter, all of this cracks open and basically destroys the ozone. I just explained that. Yes, and the UV actually is absorbed by the ozone, just like the sunblock here. So this is like the Earth has a sunscreen. And yes, I didn't mention this here. Yes, so this here is the electromagnetic spectrum. So this is the light that we can see. And the camera that's here is actually looking in the ultraviolet. So that's high energy. light, you get X-rays down here, and then all the way up here, this is the infrared, which we'll talk about later. But the UV is what generates the ozone, and it also is what absorbs the ozone, so it's basically the Earth's sunscreen. There we go. And when you have this in it, it captures that and it eats up the ozone, which is the big problem. So that was another thing that I struggled with a bit, was just the fear of what's up in the atmosphere, because it was basically burning me. So that was another thing I remember quite vividly. The next thing is, where did I get my first conspiracy theories? It was at school. So, interestingly, most churches in particular we're called to pray for our governments as Christians, and many of us do. We pray for those who are in power, and we trust God that God has put people in power in order to basically keep the rule of law. And many times in the past, and the Bible explains Christians being right in the midst of those rulers, even the most awful rulers, gently guiding and leading in the way that God wants things to go. So it was not in the church that I had my anti-government views, it was at school. Of course, an English teacher, And the English teacher had come over from the States because he thought the world was about to end. And for our speeches, he said, everyone here has to choose a different conspiracy theory. So we all had to pick a different conspiracy theory, and then we all had to do our speeches, our 3-minute speeches at school, on a conspiracy theory, which, I felt was quite unfair because I wanted to choose what I did. Anyway, so there was obviously the classic ones around the moon, and some really awful ones as well, like thinking that a whole bunch of killings and things were done by the government and not by specific people. So it was mainly anti-government sentiment. And actually, at this stage, my father was very, very good at helping me critique those historical narratives. He was really good at helping me go through and say, well, yeah, we can't trust the government all the time, but in order to construct such a conspiracy theory, you would require everyone to be in on it. And humans are not that organised. and that's why these conspiracies that do exist, there are real conspiracies that the government has in the past conspired secretly to change, to do things, but they come out. And you can actually track how many people you would need in order for it to come out and how many days basically it would take. And basically as the number of people goes up, it's basically always out within a year. So, and that actually shows just the way in which we do actually want to talk about things. And so he was quite good at that, and he had some training in sort of, and he was very interested in history, and so he helped me a lot with this. But when it came to scientific matters, that wasn't my parents' expertise, and so this is where I went a little bit on my own. So the first thing that my English teacher was telling me about is about peak oil, okay? And peak oil had been predicted in the 1950s by Hubert, and he basically said, looking at the way in which America is producing oil at the moment, we are almost about to hit peak, and we're about to decline, and all of the benefit of the oil that we've had over the years is going to go away, and we're going to be back in the Dark Ages. So quite apocalyptic views. There is octane, which is the petrol molecule, if you were wondering, carbon and hydrogen, and there's 8 of them. That's why it's called octane. The other thing, this really mattered to my community because we imported all of our oil, and prices were spiking at that time. We were really concerned about the prices. And the prices were matching what the prices that people had in the 1970s, which were very, very high because of the reduction of oil by the OPEC countries. So this was sort of quite concerning for at least people in my community who just couldn't afford to drive around. So it was quite a big deal. And I was told about in the 1970s how petrol was so expensive, people would be queuing up and that everyone at that stage was trying to figure out what fuel they would run their car on that didn't mean that they needed to put petrol in it. So a lot of people converted to LPG cars, and I remember chatting to some old mechanics, them showing me all their different gas carburetors and how they used to run the car on LPG, and it got me really thinking, what is the fuel of the future? Of course, the crisis is averted. We still have lots of oil. And part of that, I've actually learnt now, is due to scientific breakthroughs in surveying. We can now find all the little pockets of oil under the earth. The US didn't actually decrease because it worked out ways of fracking, so it could increase its oil production. And you can see that while America did perhaps peak in Texas, that hasn't stopped the rest of the world for picking up that slack. So yeah, it's not happening. But again, I was sort of looking at data here and freaking out a bit. So the second science fair project I did was trying to make hydrogen, okay? So I can't find a picture of it exactly, but this is as close as I can get. So you can see a battery, I've got some pieces of metal, and I put electricity over it and I get bubbles. And of course this means I can make little explosive pops, which was fun for a 14-year-old. What I was doing is getting the water and I was putting electricity in and I was getting hydrogen and oxygen. And then, to my great joy, was recombining it and was creating water again. So in a sense, it's a battery. And you put energy in, you get the hydrogen, you can release it. You can either make a little flame, is what I did, or you can actually put in a fuel cell and create electricity. And so this was what I was doing. Now I went to the science fair this time and I won best in my age bracket. I got $300, which was like, I remember thinking at the time, you can get paid for doing science? It just never occurred to me. I thought, surely not, you know. And the first thing I did is I went out and bought a tool chest. Oh, so good. Still have that. So yeah, that's what I used that money for. And so I got thinking, I have to do something even better, you know, better the next year. And so I wanted to do some really good research. And as you can imagine, this is where it all goes downhill. So, yes, fringe science. So I'm not, skeptical science is not really what it is. Fringe science is where it's not mainstream. So there's very few people who are practicing scientists that would believe these specific things. But usually this comes along with anti-government sentiment that says that the government's controlling what you're saying, and so these people are sort of speaking out about these fringe views that they've discovered that they want you to know about, but they're being suppressed. And so it's quite actually an attractive way of framing it. And of course in there was climate denial as well. And I just wanted to show you sort of what it looks like. A lot of what I saw was a mixture of amateur science, so people just explaining science and just doing it as a hobby. It was a combination of anti-government sentiment, and it was also just sort of a lot of stuff to do with sort of build it yourself. So that was kind of the vibe. And so what I did for my third science fair project is I created a carburetor that could mix water and petrol together in order to increase the efficiency. Now, this does work for a little bit until the entire motor seizes because you've put water in an engine and it's just going to seize. So anyway, I took this to the science fair and I was super excited. I had a little scooter that was running. I was super excited. I was even in the newspaper, me on the scooter. And the scientist, the physicist that judged me, basically took me aside and said I wouldn't receive any prize this year because it's not science. It was fringe science, and I was really annoyed, very annoyed at this. How dare he try and cancel me? You know, I had there's a lot of people. I'd made it. It was working. He could see it was working. You know, like how could he now doubt the science? And he said, look, you've made it work, but you're not explaining it right. So what he said is that he'd mentor me for the next year. And he actually got me in contact with people at the university and engineers, and with this group of people, I could send them links, and they could say, oh, that's not ideal. And so they started to help kind of place these different ideas and say, look, actually, there is some good science in there, but a lot of this other stuff that you're seeing around plasma and free energy, that isn't going to work. And I actually... And actually, they showed me later how to prove that as well with maths. And so for the fourth science fair, I decided to work on, in order to fuel cars when there was petrol shortages. So this is actually a furnace. You put wood blocks in it, and you can turn it into a gas that you can run an internal combustion engine on. And there was over 1 million of these during World War II that were running. And so that's what I did. I built my own little gasifier. And just to show you kind of how that works, I get wood, which is a bit of cellulose, which is this kind of sugary chain of molecules, of atoms, sorry, and I add a little bit of oxygen. And instead of getting carbon dioxide and water, I get hydrogen and carbon monoxide. So it's sort of like half the oxygen goes in, and then I put the rest of the oxygen in, and then I burn it completely to water and CO2. So it's sort of like I'm doing half of the burning here, and I'm doing the other half of the burning inside of the engine. And you get out the little, the cute little water molecule and the CO2 molecule there. Cool. Now, this did a lot better. And I had lots of people who were very interested in it, and some great puns were had around the wood-powered engine. And so I did well at the Waikato Science Fair, and I actually got a lot of money, which for me was, it's very exciting. And then they told me that there's actually people from every science fair around the country, and we're all going to come together and we're going to do a national science fair. And I was like, ooh, a national science fair. So we went all the way down to the capital city. We got flown down, and this is, you can see I'm sort of sticking out the back there because I am tall. And this was incredible. So we spent a whole 10 days touring around research laboratories all around the country, and we got to meet scientists. And this is really where I started to have my sort of views quite gently critiqued, but firmly critiqued. So the first place that we went to was where the fart tax was going to go. So this is a dairy research centre, and we had to be quite careful in this rotary milking shed to not get covered. You have to be very careful. Look for the tail. That's what we're told. And of course, this is the methane here that's coming out of them burping. And I got to meet the scientists, and I got to see them, with the petri dishes and trying to make sure the cows were healthy. And I saw these people there was even a cow that had sort of a bung in the side of it, and they were like taking grass out the side of the cow, and it was incredible, And by the way, these fistulated cows are the most well looked after cows. They live for a good few years longer than the average, so they're the best looked after cow. And so, yes, this sort of idea that you could modify the feed in order to reduce the methane emissions. And they actually had, by adding algae and seaweed to the food, had huge reductions, so over 50% reductions in the amount of methane. And this was actually where the fart tax was supposed to go. And I was like, cool, this is actually really quite awesome. And they worked really closely with the farmers, and they really cared about the animals too. And their goal wasn't to remove the animals from the farms, but was to basically try and understand how to solve this problem, which is the amount of methane that's being emitted. And they also said to me that the cows that are farmed outside, and the way that you farm outside, can actually make these cows produce the least amount of emissions of any cow around the world as well. So it was sort of saying we're doing very well and we're improving every day. So that was very encouraging to hear, and quite a different view from what I'd heard. And then the second place we went to was the Atmospheric Climate Research Lab. So this is the place where they measure CO2 in the atmosphere. And I, for a long time, thought, can you even measure that? Like, that seems a bit wild. But they showed me. They showed me how they measured it. And I'll just go through that just very quickly. So you get this container, and you attach it to a vacuum pump, and you suck all the air out of it, okay? So it's basically got all of the nitrogen sucked out. So this is actually a vacuum. And then what you do is you go outside, and you turn the stopcock, and it goes, and all the air gets sucked in from outside, and then you close it, and then you bring it into the lab. And then what you do is you basically pour liquid nitrogen on it, and I can talk to you about how we make that. It's not too hard. And then the CO2 actually turns into a solid because it's got a freezing point higher than the boiling point of nitrogen. And so you get this little lump of dry ice, and you can get rid of all of the other gases around it because you can pull a vacuum on that. And then you've got this little bit of CO2, you let that heat up, and then you basically push it against a column of mercury. And you can figure out how much gas there is because you've pushed this much mercury down, and you can work out how much that would be against the weight of the mercury here that's been pushed up. And they literally had a telescope that allowed them to look at the height of the mercury so they could get it exactly. And out of 1 million gas molecules, about 400 are carbon dioxide, and they could measure 1 molecule in every 10 million gas molecules. Accurate. So that was the accuracy, which was incredible. So they could measure that small amount. So at the moment, before we emitted greenhouse gases, this was about 280, and so we've gone up to 400 parts per million. And you can see that we're actually able to measure that at the accuracies that are required, which is pretty cool. I don't have time to go through how it was measured up on the top of the mountain, but needless to say, they used a microphone. And they basically flashed light on the CO2 molecules, and they listened to the CO2 molecules absorbing the heat, and that was actually picked up with literally a condenser microphone. So similar to an amplification circuit. And so they literally were listening to the CO2 levels basically near where I was. They had one of these pieces of equipment. It's called a photoacoustic detector. And that allowed them to measure the CO2 levels going up and down, but over time increasing. So it goes up and down because in the summer, the northern hemisphere's summer, all the trees absorb the CO2. And so the Earth actually breathes by 10 parts per million. And so that's where this little fluctuation is. But you can see that the trend is upwards. So CO2 is going up. Right. So the last place that we went, the next sort of research centre that we went to, actually had, it was a physics department, and they had this really cool infrared camera. And so this camera could actually look at the heat that's coming off your body. Right. And so just to break it up a bit, I have got the newest version of that, which is a little bit smaller, as you can see. And I'm just going to plug that in. So what this has inside of it is basically a whole bunch of thermometers that are arranged in a grid, and those thermometers are looking at all of you, and what you should be able to see is that, sorry, I'm going to put it here first. What you should be able to see is you can see, that's better. Yeah, there we go. So everyone who is at 37 degrees is emitting light at the moment into this thermal camera. So I'll just... So, and the cool thing is if you've got glasses, you can actually see it. The glass from this is blocking the infrared light coming from my face, and that's why you don't see the glasses. And so this is, I thought this was so cool, this thermal camera, because what it's doing is it's actually looking at the way that we cool down. So we actually all the time are emitting light, infrared light and visible light, and that's how we cool down. And it's all the way out in the infrared, and that's exactly how the Earth cools down as well. So the sun heats up the Earth with visible light, because the sun actually emits light in this regime, and then the Earth, which is sort of about 20 degrees, is emitting light a little bit further in the infrared than we are. And this is actually what the Earth looks like if you have a satellite that has one of these on it. So it actually looks like it's glowing. And you can see you can't see the Earth or the continents, because all of the gases are the things that are emitting the light at the top of the atmosphere. And at the top of the atmosphere, that's actually where all of the heat is lost, and there's no water there. So in effect, it's CO2 that's wobbling like this. This is the way in which it absorbs the far infrared and this light, and then only a small amount comes out. And you can actually measure with satellites and see that the amount of heat coming out of the Earth has dropped. So we're actually putting more heat. So yeah, when this light gets absorbed, it can be shot back at the Earth, and that's why we basically heat up. And one of the nice experiments that you can do is if you have a can of methane, you put it in front of a heat pad, you can see that you're reading a lower temperature here than over here, and that's because this methane gas is absorbing the infrared light from here, and that is a greenhouse gas. Okay, so it basically makes it look like it's not as hot from outside, but that's because all that heat is being reflected back, like a blanket, basically. All right, so the next place I visited was the ice core research facility. Now, I was a teenage boy, so I decided that the most appropriate thing to do was to, with my friend, to take our shirts and to run into the negative 40 degrees Celsius room and see how long I could last. I didn't last very long. We ran back out. It's very, very cold. And this has all the ice cores that are drilled in Antarctica. And inside of that, you can actually see the little bubbles that are stored inside of this. And each of these bands is a different year. So you can basically figure out when each of these pieces was deposited. And this lab, which I visited, I don't have a picture of it, this is a more recent picture, takes those little bubbles and it measures the amount of CO2 in there, but it also measures how heavy the water is in there, the oxygen, and how heavy the carbon is. And it turns out that if you can weigh atoms. I'd love to go into detail. Ask me later. You actually basically use a magnet, and depending on how heavy things are, they'll be deflected by different amounts. And then you basically can figure out the different masses. And it turns out that if you've got old carbon, it only contains the very light carbon isotopes. And if you have heavy water in there, it means that the ocean was hot. Because if it's not so hot, the heavy water just stays in the ocean. And you have to heat it up a lot more. Then the heavy water will go up. It only weighs a couple of % more, but it is enough to make a big difference in the atmosphere. And what you can then do is you can go back in time and you can figure out what the concentration of the carbon dioxide is and the temperature, which is wild to be able to do that back millions of years. But I was ready for this. I'd been trained on the internet and YouTube videos. I knew how to rebut this specific point. There's a temperature lag. So, in front of everyone, and in a talk, I challenged the climate scientist. And I said, look, the temperature is changing, and then there's a lag in the CO2. So, it's clear that temperature is controlled by the sun, and that the CO2 doesn't control the temperature. Causative logic dictates that it's actually the temperature that's the most important thing and not the CO2 level. And what the scientist did, she actually answered my question, which she didn't sort of get offended And she answered it. She said, absolutely, that is the case, that a lot of this change was dependent in the past on the sun, solar activity. We can actually relate most of this to solar activity. But it's only in the last little bit that we're actually seeing the inverse, where the CO2 is going up and temperature is lagging it. So it's actually the exact opposite. So that actually shows that it's anthropogenic. And she also showed me that basically we can see that all of the carbon that's emitted is this light form of carbon, which means it's old. So it's definitely from us burning CO2. So she could tell me exactly where it had come from. And she also made me see that in the last 10,000 years, the temperature has not moved by about 0.3 degrees. And she said what's happened in the last 10,000 years is agriculture. And agriculture relies on the temperature being the same, so that if you plant something here, it'll grow again the next year. And we're now heading towards 1 degree of warming from that, which is a place that we haven't been in I think 22 million years, at least the CO2 level. So that stable temperature is actually very important for us. And the fluctuations, while they are natural, it's actually been very good that there hasn't been fluctuations in the short time that we've had agriculture, and that was quite important. She also showed me this website that actually looks a little bit sus. But it's an incredible website. Maybe that's actually the point, because they don't want people who are mainstream scientists. They want people who have questions. And what they do here is the guy who actually does this, he's actually he's an Australian researcher, and his father was a skeptic. And so what he did is he got all of the different arguments that the skeptics have here, and he got climate scientists to write a detailed discussion about it. And they explain it in a basic, intermediate, and advanced level, which is really great. And this really impacted me because for the first time, all of my arguments were answered, and I was silent. But I didn't really connect it to my faith. So this is the last little bit here. The two people that really helped me do that were Graham Finlay, who's a cancer researcher, and Nicola Hoggard-Cregan, who's a theologian. Graham Finlay was teaching in the health department, and he actually did a whole course on the health impacts of climate change. And he showed me how actually the people who will suffer most with sort of a changing climate are the poorest, and that there are real impacts to our health. And he really connected to me this idea that the people who have emitted the most are the wealthiest, and they can afford to adapt, but the people who are the poorest won't be able to adapt. So it's fine for us to sort of build levees and stop the water coming in, but if you're on an island, you know that rise in sea level can't really be adapted. And also, when it comes to the agriculture, that's a big part of health as well, everyone getting enough food. And we're already seeing that agriculture is having to adapt and shift around, and it's going to become more challenging. The other person that helped me was Nicola Hoggard-Cregan, and she helped me because it's very hard to think about something that you've done for a long time, emitting CO2, and think about the impact that you've had. And Nicola had this idea of the wheat and the tares. So basically, it's a parable that Jesus tells about the wheat and the tares. Now, tares are basically a weed that's grown, and in this parable, the tare, or the weeds, have been planted in amongst the wheat. And the people saying, look, your enemy has planted these tares, these weeds, what do you want us to do? And the landowner says, well, if you take out the tares, the weeds, you're going to pull out the wheat as well. Wait till the end of the harvest, and I will then separate the wheat from the tares. And so she kind of applies this to technology and says that it's often hard for us to figure out and disentangle the good from the bad when it comes to technology. For example, fossil fuels. And at the moment, we're trying to disentangle these two things. We've gotten an enormous amount of good from the combustion of fossil fuels, but we're now starting to get some really bad impacts as well. Now, what's really important for Christians is to think about not planting any more tares, I think is the idea. And once you realise that this is going on, trying to stop the spread of tares as much as possible and tend to this earth. And I know some Christians think that, we should be thinking more about the life to come after death, but God never abandons creation and wants to redeem us as well as creation. And so I don't know how that's going to work, but creation must be part of that. Jesus has a body for a reason, a risen body, because we're not disconnected from from the world. The other thing I learnt is that the former chair of the IPCC, which is the Intergovernmental Panel for Climate Change, and actually the person that set it up was Sir John Horton, who was a very strong evangelical Christian. And this kind of was quite shocking, I suppose, because I'd been taught that this was quite a bad organisation. And he's actually written a more recent book called In the Eye of the Storm, which is his autobiography. He talks about his faith and how he wanted to bring everyone together, even the fossil fuel companies and people that had contributed and even obfuscated the truth, because he wanted everyone to have an opportunity for redemption. And he wanted everyone to be at the table. And if people didn't want to contribute to the solution, then it would become clear. But he wanted to give everyone that opportunity to do something different. So I'm not going to talk about the rest of what I did. I spent most of the time I spent on pollution reduction, and now I'm on batteries. And I think I just want to encourage you to do what you love to help the climate as well. Maybe talking, I think talking is very, very important when it comes to this. And I even managed to have a chat at a climate conference with someone who attended, who had sceptical views, and it was great to be able to engage and to talk about that. So I encourage you all to do that. Catherine Hayhoe, who's also an evangelical Christian and is a climate scientist, she says that the best thing that we can do is to talk about climate change. But I just want to add here that if we don't talk to people with respect and grace, that's the quickest way to stop the conversation. So it's not enough just to talk about it. We have to talk about it in such a way that people want to keep talking to us. And I just wanted to thank you for coming tonight. And it is, we can have some conversations afterwards about the talk. If you do have specific questions, I'm keen to sort of engage one-on-one with you. Because this is sort of like a personal story, I'm sort of keen to chat about that and have a discussion about what it means in light of your life. But if you do have very specific questions about climate science, I'm happy to have, I'm going to be here for a long time, so I could definitely chat with you. So thank you very much for listening.